Welcome back to Question with Answer. In this video, we bring you part 2 of the top 10 generative AI interview questions and answers for 2025. If you're preparing for AI, ML, or GenAI roles, these questions will help you stand out. Let's dive right in. Question 1. What is few-shot, one-shot, and zero-shot learning in generative AI? Answer. Few-shot, one-shot, and zero-shot learning refer to a model's ability to perform tasks with minimal or no task-specific training examples. Zero-shot learning enables a model to perform a task it hasn't seen before just by understanding the prompt. For example, translate this sentence to French without having been trained on a French translation task. One-shot learning provides a single example in the prompt to guide the model. Few-shot learning includes multiple examples to help the model understand the task format and expected output. These techniques are particularly powerful in large language models like GPT-3, GPT-4, and Claude, where the model generalizes tasks using natural language. Few-shot learning allows rapid prototyping without fine-tuning and is commonly used in prompt engineering. These methods make generative AI highly flexible, reducing the dependency on large labeled datasets, and are instrumental in building adaptable AI applications in production. Question 2. Explain the concept of tokenization in GenAI. Answer. Tokenization is the process of converting raw text into smaller units, called tokens, which can be words, subwords, or characters, depending on the model's design. In generative AI, especially in transformer-based models like GPT, tokenization is the first critical step in text processing. These tokens are then mapped to numerical embeddings that the model can understand and process. Most modern LLMs use byte-pair encoding, BPE, or sentence-piece tokenization to handle various languages and rare words efficiently. For instance, the word tokenization might be split into tokenization in BPE, while emojis or unseen words can be broken into byte-level subunits. Effective tokenization ensures that the model understands context while keeping input size manageable. It also affects the model's vocabulary size, performance, and training efficiency. Misaligned tokenization can lead to poor generation quality, so tokenizers are often customized during model pre-training. Question 3. What is hallucination in large language models or LLMs? Answer. Hallucination in LLMs refers to the phenomenon where the model generates information that is factually incorrect, fabricated, or misleading, despite sounding fluent and confident. These outputs aren't grounded in the training data or real-world knowledge but are statistically plausible continuations based on patterns. For example, an LLM might invent a fake research paper citation or provide an incorrect medical fact. Hallucinations can be problematic in critical domains like healthcare, legal, or scientific applications. This issue arises due to limitations in training data, lack of grounding, or over-reliance on probabilistic language patterns. Techniques like Retrieval-Augmented Generation, RAG, fact-checking layers, human-in-the-loop validation, and fine-tuning with RLHF are used to reduce hallucinations. Detecting and mitigating hallucinations is a major focus in responsible AI development and is one of the most actively researched challenges in deploying generative models at scale. Question 4. What is Retrieval-Augmented Generation or RAG? Answer. Retrieval-Augmented Generation or RAG is a hybrid architecture that combines a retriever with a generator to improve the accuracy and factual grounding of language models. Instead of generating content purely from memory, RAG-enabled systems first retrieve relevant documents or knowledge snippets from an external database, then use that context to generate a response. This approach addresses the hallucination problem by grounding the output in real, verifiable data. For example, a chatbot using RAG might fetch updated information from a knowledge base or web index before crafting a response. RAG typically uses models like BM25, DPR, or vector databases for retrieval, and transformers, like T5 or BART, for generation. It is widely used in enterprise AI, search engines, question-answering systems, and AI assistants to keep content current and reliable. RAG systems can also be fine-tuned to specific domains, making them powerful tools for applications where factual correctness is essential. Question 5. What are guardrails in generative AI systems? Answer. Guardrails in generative AI refer to the safety mechanisms and constraints designed to ensure responsible and secure behavior from AI models. Since generative models can produce harmful, biased, or inappropriate content, guardrails help enforce ethical standards and compliance. Guardrails can be implemented at various levels. 1. Input filtering. Rejecting unsafe prompts before processing. 2. Output moderation. Using classifiers or rule-based systems to flag or block toxic outputs. 3. Content boundaries. Hard coding limits on topics the model can discuss, for example, no medical or legal advice. 4. Rate limiting and access control. Preventing abuse by limiting frequency or user scope. Advanced models also use RLHF and feedback loops to refine outputs based on user signals. Guardrails are increasingly important in enterprise deployments, public APIs, and consumer products to build user trust and ensure legal safety. Companies like OpenAI, Anthropic, and Google heavily invest in guardrail research to prevent AI misuse. Question 6. What is fine-tuning in generative AI? Answer. Fine-tuning is the process of continuing training on a pre-trained generative model using a smaller, domain-specific dataset. This allows the model to specialize in particular tasks, tone, or knowledge domains. For instance, a base LLM like GPT can be fine-tuned to generate legal documents, write marketing copy, or assist in medical diagnosis. Fine-tuning adjusts the model's internal parameters using new examples, improving relevance and performance. It typically involves supervised learning and may require significant computational resources depending on model size. While effective, fine-tuning is less flexible than prompt engineering and requires retraining if the task changes. That's why lightweight techniques like LoRa or low-rank adaptation, and PFT or parameter-efficient fine-tuning, are gaining popularity to reduce cost and complexity. Fine-tuning is ideal when your use case demands highly consistent outputs in a fixed domain. Question 7. What are diffusion models in generative AI? Answer. Diffusion models are a type of generative model used to create images, audio, and even text by reversing a noise process. They work by gradually adding noise to training data and then learning to reverse this process to generate new, realistic outputs from pure noise. Popular examples include Stable Diffusion and DALL-E2. Unlike GANs, which can be unstable to train, diffusion models are more stable and produce high-quality samples. They've become the standard for image generation tasks and are now being explored for multimodal applications, including text-to-video and audio synthesis. Their main advantage is the ability to generate fine-grained, detailed images with high fidelity. However, they are computationally expensive and slower compared to other architectures. Despite that, their quality makes them a leading choice for AI-generated content in creative industries. Question 8. What is prompt engineering and why is it important? Answer. Prompt engineering is the practice of crafting and optimizing input text or prompts to get desired outputs from a generative model. Since models like GPT-4 or Claude respond based on the input prompt, even small changes in wording can significantly affect output quality. This technique is crucial because it maximizes model performance without additional training or fine-tuning. Examples include using few-shot prompts, instruction prompts, or structured formats, like JSON, to guide outputs. Effective prompt engineering ensures outputs are relevant, accurate, and aligned with user goals. It's especially useful for customer support bots, content generation tools, and coding assistants. In production, Prompt engineering also supports dynamic behavior, allowing a single model to handle multiple tasks based on how you ask it. It's a key skill in deploying scalable GenAI solutions with minimal compute cost. Question 9. How is GenAI used in real-world applications? Answer. Generative AI is being rapidly adopted across industries for automating tasks, generating content, and improving customer experiences. In healthcare, it's used to draft medical reports and summarize clinical data. In finance, GenAI helps generate risk reports, automate customer service, and assist with fraud detection. In media and marketing, it creates ad copy, social media posts, and design assets. Education platforms use GenAI for personalized tutoring and content summarization, while software companies leverage it for code generation and bug fixes. Creative fields use GenAI tools like Midjourney, DALL-E, and Runway ML for artwork, video editing, and design prototyping. Enterprises also deploy GenAI in chatbots, document processing, and summarization pipelines. Its flexibility and human-like output make it ideal for augmenting human work, reducing costs, and scaling operations. With responsible usage, GenAI is transforming how businesses innovate and operate. Question 10. What are some ethical concerns with generative AI? Answer. Generative AI raises multiple ethical concerns, primarily due to its ability to generate convincing but potentially harmful content. Common risks include bias, misinformation, deepfakes, plagiarism, and data privacy violations. Since models are trained on large, uncontrolled datasets, they may inherit and amplify societal biases or stereotypes. This can result in discriminatory outputs or unfair recommendations. Misinformation is another challenge. Models may hallucinate facts, leading to misleading or incorrect answers. Deepfakes and fake news generated by AI pose a threat to public trust, and unauthorized content generation can infringe on copyrights or violate user privacy. To address these concerns, developers are focusing on guardrails, eye alignment, transparency, and human-in-the-loop systems. Ethics in GenAI is now a top priority for enterprises and regulators alike, ensuring the technology benefits society without causing harm. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.